Today in class we're going to talk about electrolysis, and this is a special type of electrochemical cell. If we go back to that PowerPoint over electrochemistry, there were two types. We have been studying so far voltaic, or also galvanic cells, and those are cells where you get a chemical reaction, and the chemical reaction will actually produce a voltage, and those we call spontaneous. What that means is they're just going to happen without us really doing much to them. They're just going to happen. So if we look at this, I've downloaded this worksheet or uploaded the worksheet so you can get to this worksheet. This is for your notes. Electrolysis reaction that is non-spontaneous, meaning it really wouldn't happen without us doing something for that. So if we look at this reaction of sodium ions and chlorine ions coming together to make sodium as a liquid and actually chlorine as a gas, this is actually a non-spontaneous reaction, which is a good thing, because if we were just to take salt and to put it in water and form those ions, we sure wouldn't want it to all of a sudden start making chlorine gas. But if we were to shoot some voltage through that, we could actually force this reaction to take place. And so we would need about 4.07 volts, and we would need to shoot it through. We could actually force the sodium and the chlorine ions to oxidize or reduce and become sodium liquid or chlorine gas. So that's what makes this a little bit different. You're not going to have to draw these. This drawing is just for you can see that one of the main differences between what we've been drawing, the voltaic cells, is this is not a voltmeter here, but this is actually a voltage source, kind of like a battery would be. And a battery has a positive and negative side, and electrons always flow out of the negative side. So this is a battery. I gave the example in class. If we wanted to break apart water, well, water doesn't normally just break apart into hydrogen and oxygen. If we were to shoot some voltage through that, we could make the hydrogen and oxygen come apart from one another. So that's an example of electrolysis. We do this sometimes with plating out metals. We can cause one metal to come out of solution and to go on to another metal. For example, when they make silverware, they plate out the silver and they plate it onto something else to make the silverware. And it takes voltage, so it's kind of an expensive process to do. So I have some comparisons between the two cells. What we've been studying so far is a voltaic or galvanic cell, which is also known as a battery. And it produces voltage from a chemical reaction. And we talked about the anode was the oxidation, the cathode was the reduction. We talked about the negative being the anode and the positive being the cathode. So that's what we did in lab, and that's what we studied up to this point. Electrolysis, on the other hand, is pretty much opposite definition. This time you can produce a chemical reaction by actually adding voltage. You have to send some electricity through it to make the chemical reaction take place. The anode is still oxidation, the cathode is still reduction, but as far as the labeling, when we label those cells, we label the anode as positive and we label the cathode as negative. And here's the reason. The polarities are different because in a voltaic cell, the negative electrode, which is the anode, is where the electrons are being produced. In an electrolytic cell, the negative electrode, which now is actually called the cathode, is where the electrons from the outside source is being pumped to. So when we come up here, if we were labeling this one, this is actually going to be labeled, it normally is labeled positive, but in this type of reaction, we actually labeled this negative. So not a huge difference other than the polarity has changed. This is only for an electrolysis cell. And again, you won't have to draw that, but I would like you to know that the polarity changes. Alright, then what we really did was work with some problems with it. And for time's sake, because this is shorter 6 weeks, we just focused on what is current, what is coulombs, and we use this formula here, which is called I guess it doesn't have a name for it, but coulombs equals amps times second. And it makes a nice little triangle. Little q stands for charge, and charge is measured in the units called coulombs. If you've had physics, you might have studied about coulombs. And then I call this my quit formula because it has an I and a T, and it kind of looks like the word quit. T stands for time, and time is going to be measured in seconds. I stands for current. And current really is like a speed. It's how many electrons are flowing through the wire in a given second. So we say it's either in amps or in coulombs per second. It is our I in the equation. So amps is actually the unit. It's actually short for amperes. So we've got amps, or you could write out coulombs per second. Either one of those are correct. So it's like a speed, like miles per hour, meters per second. These are coulombs per second. How many electrons are flowing through the wire in a bit of time? And so what we're going to do is to do some problems. Since I'm in Microsoft Word, this doesn't work quite as well. We're going to look at these 1 and 2. We are actually not going to do problem number 3 for time's sake, so you don't have to worry about that one. I'm going to put my little formula over on the side, which is QIT. And we're looking for grams of copper. And grams of copper, well, the only way we can really get to grams is by getting to the mole. In your notes up at the top, I'm not going to scroll to the top because it's going to disappear because I'm in Microsoft Word. It said that for every mole of electrons that we have, that equals 96,500 coulombs. That is a number that you need to know. For every mole of electrons, there's 96,500 coulombs. The abbreviation for coulombs is capital C-O-U-L. So I could get to moles, I could get to grams, but the problem with this conversion is that this is moles of electrons. I need to get to moles of copper, because if I'm looking for grams of copper, I need moles of copper. This is where I need to write a half reaction. And I really meant to put a Roman numeral 2 in this equation, because this is copper 2 sulfate. So I would write a half reaction. It says it's being reduced, so we are actually making copper metal, because you're plating out, so your metal is going to be over here on your product side, and it is a reduction. So these ions are getting reduced. If I balance this out, this is a reduction. It's got 2 electrons. You're going to want this because this is going to give us a mole-mole ratio. For every 2 moles of electrons, there's actually 1 mole of copper. So this is going to be useful here in a moment. So somehow if I could get to coulombs, I could get to mole. Once I get to mole, I could get to copper. Once I get to moles of copper, I could get to grams. So my goal first is I got to get to coulombs. Well, according to this, if I take the I times the T, that's going to get me the charge. So Q equals the I times the T. My I is 5 amps. I'm going to write it out as the other just for you can see. 5 coulombs per second, just for you can see the units canceling out. I'm going to multiply that. Guess what I've got to do with the 35 minutes? I've got to convert the 35 minutes to seconds because time needs to be in seconds. And so that's 2100 seconds, just multiplying by 60. If you can see, the seconds are going to cancel, and that's going to leave me with coulombs. So now I will have 10,500 coulombs. Well, now I've just got a tic-tac. I'm going to have to move that because I'm going to run out of... Oh, that's not what I meant to do. Let me go back. I want to erase. I'm going to move this equation down for I can see because I'm going to run out of room over there. We had copper plus 2 plus 2E minus made copper. Alright, so I'm going to bring coulombs down, and from coulombs I can go to moles of electrons. Here's our conversion up there. It's up above on this sheet of paper, but if I scroll up, it's going to make everything else disappear. So for every 1 mole of this, I have 96,500 coulombs. So coulombs will cancel. If I stop right now, I have moles of electrons. I don't want moles of electrons. I need to get to moles of copper. So now, just like in stoichiometry where you have a mole-mole ratio, for every 2 moles of electrons, I'm going to have 1 mole of copper. And once I have, that's going to cancel. Once I have moles of copper, I can very easily go to grams of copper because moles and grams talk to each other very well. But I need to be in moles of copper, not moles of electrons. And then this is going to come straight from the periodic table, 63.6. I'm going to multiply across the top. I'm going to divide by the bottom, and I'm going to get my answer. And I'm having to do this in the calculator because I don't have this written down. And so you should be coming out with 3.46 grams of copper. So I basically have zapped this copper 2 sulfate for 35 minutes, 5 amps, and I'm only getting 3.46 grams of copper. So this is not a very productive thing here. So electrolysis is kind of expensive to do. That's why our metals and stuff are, if you've heard of electroplating and like your chrome bumpers and things, that's why they're expensive. Let me back up for 1 second. I only wrote a half reaction here. The sulfate is a spectator here, so that's why I didn't write the sulfate in it. So you're really looking at plating out the metal, you're looking at the metal and the metal's ion. Just the reduction equation, pretty much the reduction. Sometimes you're looking at the oxidation, but again, you're only looking at half reaction. Alright, so now if we look at this next example, let me erase this. We are looking at, it says, how long must a current of 6.5 amps be applied to a solution containing aluminum ions to plate out 0.55 grams? So how long means I'm looking for time. So time, I'm going to write up here, is the Q divided by the I. Now I have the I, and the I is, again, I'm doing this problem, so you're going to have to ignore this one up here. Sorry. 6.5 amps. I know that one. I do not know the Q. So I'm going to have to find the Q, which is coulombs. So I need to write my half reaction. Well, I'm making aluminum metal. So he's going to go over there. Aluminum ions. Aluminum's always a +3, so I will have 3 electrons going on. So I'm going to begin. I have 0.55 grams of aluminum. And I would then convert this to the mole. So 1 mole of aluminum. I'm going to pull this from the periodic table. This is 27 from the periodic table. That'll cancel. Now I'm ready to do mole-mole ratio. I'm going to get rid of the mole of aluminum, and I'm going to go to the mole of electrons. If we look in our equation, there are 3 moles of electrons and 1 mole of that of aluminum. Alright, I'm going to keep going because now for every 1 mole of electrons, there are 96,500 coulombs, which is what I was looking for. So I'm going to multiply 0.55 times 3 times 96,500 divided by 27. And you get 5,897.222 repeating coulombs. Well, this is going to go right up here because I'm looking for the charge, which is coulombs, divided by your amps. So now that I've got it in the calculator, I'm just going to go divide by 6.5, and you're going to get that this is 907 seconds. So if I were to, now there's only 2 sigdigs going in this, I think I want to put this in minutes because it makes a little bit more sense. So I'm going to divide by 60, and what this is going to come out to be is 15 minutes. You could have left it in seconds. You would have rounded to 910 seconds if you left it in seconds. So 910 seconds or 15 minutes. And that's pretty much it. We're just going to be using this formula, writing those half reactions. I have uploaded the worksheet, so if you're absent, you can print the worksheet out. Out beside each problem is the answer, so you can check yourself. And then we also do have a quiz on this. So give me a call or anything, or I guess you can ask me a question on Edmodo. You can't call me anymore if you have any questions over this. So it's really not that hard. Have a terrific day.